Welcome to the Explainer. You know, it's funny. We use the internet for basically everything, but have you ever stopped to think about what's actually happening under the hood when you send a message or stream a movie? Well, today, we're going to peel back the layers on the hidden machinery of the internet.
So let's just start with what seems like a super simple question, but one that has a surprisingly complicated answer. What are we actually talking about when we say the internet?
The best way to get your head around it is to think of the internet as a two-sided coin. See, on one side, you got this massive, sprawling physical machine, a globe-spanning web of actual cables, computers, and switches. But then you flip it over, and on the other side, it's this invisible platform that brings us everything from our favorite shows to our daily emails.
Okay, so let's dive right in. We're going to start with the physical hardware first, what we're calling the nuts and bolts view of the internet.
Now, this image might look like a totally chaotic web of connections, but it's actually a pretty beautifully organized system. And we can break this whole global machine down into three key components that make it all tick. First up, you have what are called end systems. It sounds kind of technical, but it's just a fancy name for all the devices they actually use every day. Our laptops, our phones, even those huge servers sitting in giant data centers. They're called end systems because they sit right at the edge of the network. They're the beginning and the end of any data journey. Next, we've got communication links. You can think of these as the physical highways for our data. We're talking about everything from the fiber optic cables buried under our streets to the invisible radio waves that give us our Wi-Fi and cellular service. This is literally the stuff that carries our digital world from point A to point B. And finally, we have packet switches. These are the traffic cops of the internet. Devices like routers and switches take all our data, which gets broken down into these tiny little pieces called packets, and they direct them through this digital maze, making sure they get to their destination. So here's the really crucial part. All of these components, our devices, the links, the switches, they're all tied together by internet service providers, or ISPs. And this is what creates this vast network of networks, connecting your little home network to your university's network, and that to a corporate network, and on across the whole world. Okay, let's flip that coin over now. We've seen the hardware, so let's see how all of that builds into the second view, the internet as a service platform. I mean, let's be honest, this incredible hardware infrastructure really exists for one reason: to power the apps we can't live without. We call these apps distributed because they're basically a conversation between multiple devices, like your phone talking to a Netflix server, all working together to bring you that movie or show. And most of these apps use a really common pattern called the client-server model. It's actually super simple. You've got a big, powerful computer, the server, that offers a service like hosting a website, and then you have your device, the client, which requests that service. That's it. But this brings up a really key question, right? How do these applications, these programs running on our devices, how do they actually tell the physical network what to do? How do they give it instructions to deliver our data? The absolute perfect analogy for this is the good old-fashioned postal service. You wouldn't just scribble a note and toss it out your window, right? No, you'd use an envelope, an address, a stamp. The internet works the same way. It has its own set of rules called a socket interface, which is basically like a digital envelope and address label that makes sure your data gets to exactly the right place. So how do we connect these two worlds, the physical nuts and bolts and the digital services we use? Well, the hardware is the how, right? It gives our data a path to travel. And the services are the what, the reason we're sending data in the first place. This slide just brings it all together perfectly. On the left, you see that physical network we've been talking about. And then on the right, we have this abstract, layered model that shows us the software and the rules that bring all that hardware to life. Each layer has a very specific job, and they all work together to make the whole thing function. The bridge, the secret sauce that connects the hardware and the services, is something called protocols. You can just think of them as a universal language that all the devices on the internet have agreed to speak. For example, there's a protocol called HTTP. That's what lets your browser talk to a web server to load a web page. It's these shared rules that make a global internet even possible. So what's really cool about this model is how it organizes everything. I mean, it turns what could be total chaos into a really manageable system where each piece has a specific job to do. It's basically the blueprint that lets engineers all over the world build and troubleshoot this unbelievably complex network without stepping on each other's toes. Okay, let's zoom out for a second. We've talked about hardware, we've talked about services. Why does understanding this split actually matter today? Here's the key takeaway. The internet is both a physical reality and, at the same time, this abstract, endless frontier for innovation. It's that magic spot where the tangible world of hardware collides with the limitless world of software. And understanding both sides is what's really key. And this matters more and more every single day, because the very definition of an end system is just exploding. Seriously, we are no longer just talking about computers and phones being connected to the network. I mean, look at this. The number of connected things is just skyrocketing. It's not just our phones and computers anymore. We're talking about smart homes that learn our routines, cars that navigate by themselves, and entire cities that manage traffic in real time. All of these are now part of this ever-expanding internet. And that kind of leaves us with a final thought to chew on. As these two sides of the internet, the physical hardware and the abstract services, continue to merge into every single part of our lives, what new possibilities and, yeah, what new challenges is that going to create for all of us?